In this video, I'm going to start the construction of my 6L6GC. It's a single tube, a single-ended amplifier kit. It's a TU8200 by ELEKIT of Japan. I've already assembled the 80-100 series, which was the 2 watt per channel, and this is the this one can be configured in two different modes. It supports 3 different modes, and it's all selected by jumpers. And once the amplifier is complete, I'll actually demonstrate it in all 3 different modes. It can operate in what's called a triode mode. It can operate in a pentrode mode, and it can operate in an ultralinear mode. And it all is based on how the grid structure. It's a power beam tube that is being used on here, and I'll explain that when we get into it. But before we get into the construction of this, I think a little background on amplifier design is in order. And I'm going to try and draw a schematic based on memory. This goes way back. I'm just going to try and draw what I remember, and if I'm wrong, hopefully somebody won't jump on me too much, because I haven't done this in many years. But I'm going to try and explain the differences between what's called a push-pull amplifier, or Class A, B, or Class B, and a single-ended, which is the design of this, and why single-ended are much preferred in audiophile circles, because the sound quality is superior off of a single-ended amplifier as opposed to a push-pull. I'm going to try and explain those differences on paper. Okay, so we'll first start out with, this is a push-pull, a conventional amplifier. And on a conventional amplifier, we have 2 tubes that's outputting the signal. So here we'll represent 2 tubes, and we'll represent our cathode with our heaters. This is our heater, and we'll represent our plate. And I'm only going to draw these as a triode. So here's our grid, and the same on our other tube here. Our other tube, we've got our plate, we've got our grid, and we've got our cathode and our heater. We've got our output transformer, and our speaker leads, and our B plus goes into our center tap. So this is our B plus, and one side of the transformer is connected to one plate, and the other side of the transformer is connected to the other. Now this is our B plus, so this goes down to our power supply. We'll call it 300 volts. It could be higher, it could be lower. Now these 2 tubes, only one tube is on at any given time. So as the waveform goes positive, one tube will conduct, and as the waveform goes negative, the other tube will conduct and pull our B plus to ground. And how this is done by what's called a phase splitter. So we have another tube back here, another triode tube. So here's our grid coming in, and our cathode. And here's our cathode and our heaters. So we don't need to worry about drawing the heaters, but what I do need to do is and then we've got a resistor here that goes to our ground. And this is for one side of our control. I've actually drawn this off a little bit, but there's a capacitor here. And then that goes into our grid, and our plate goes in through another capacitor. And this is going to go, will be another resistor here, and this now goes back to our B plus, so we can take that back around here, connect that down to our B plus. This is our phase splitter. Actually, it should be a resistor probably in here somewhere too, so we don't want full load, so there should be another resistor in there like that, and then we're going to have a buffer tube. So a buffer tube will draw in here, and the plate from our buffer tube is going to drive the grid. That's our plate. Going to drive our grid, and we'll have another resistor here, and go back to our power supply. And here's our cathode here with a resistor to ground and our filament. And we have another our grid here. This is our audio signal coming in. And our volume control would typically be there. Audio in. Or back to your preamp. This is the most simplified drawing of this. So what happens is your audio signal comes in, your waveform comes in here. It's amplified to a bigger waveform, goes into the phase splitter. And what happens when the signal is amplified in this phase splitter, the tube goes into conduction. And as the tube goes into conduction, the voltage on the cathode will rise and the voltage on the plate will drop. And this creates an opposite effect, whereas when one voltage is rising, it'll cause this tube to go into conduction, and when this one is dropping, this tube will go out of conduction. And then when the waveform reverses and goes the other way, the tube goes out of conduction, so the voltage goes back up and the voltage goes back down on the cathode, which reverses the bias on the two output tubes. So when one tube is going into conduction, the other tube is not. And then when the voltage reverses, the tube that was going into conduction comes out of conduction and puts the other tube into conduction. So what ends up happening is one tube ends up amplifying the positive half of the waveform, and the other tube ends up amplifying the negative half of the waveform. So with the positive half going into one side of the transformer, pulling the magnetic resonance one direction, the other one, which is basically, it's amplifying the negative portion of the waveform, but it's not going negative like that. It's going in the negative wave shape, it's going up like that. So that's pulling the magnetic field, because our power is going into the transformer like this, right? And when one tube goes into conduction, we're pulling the power through one direction and creating a magnetic field in one direction. And then when that tube cuts off and the other tube comes on, now we're pulling power through this direction on the winding, which is creating an opposite magnetic field. The end result is we have a waveform coming out the speaker. The problem with this design, this is a Class B design, and Class AB is really not much different, other than the fact that we add a slight bias current to our grid to keep the tube from going into full cutoff. So we always keep a little tiny bit of current flowing through the tube at all time. Even when there's no signal, there's always a little bit of power. That way we don't get what's called crossover distortion. So at this point from the waveform, if this is our waveform and our waveform is going like this, okay, at this crossover point we get a distortion. Every time there's a crossover, this is what's called crossover distortion. And by adding a slight bias to our output tubes or our output transistors, because the same thing applies to a solid state amp, we can reduce the amount of crossover distortion that we would get in a true full Class B design. And that is what is referred to as a Class AB. But a Class AB amplifier is basically the same design as a Class B. It's a push-pull. So you're pushing your power one direction and you're pulling the other. So you're breaking your audio signal in two. That is a Class B amplifier, and most amplifiers are Class B because they're relatively efficient. The other type of amplifier is called a Class A, and for that, let's look at the schematic for this amplifier. So now we're looking at the output section of the single tube 6L6GC output tube. This is it here. This is a Pentrode design, so we've got more than one grid as opposed to our triode. So basically, here's our transformer over here. If we can zoom the camera in a bit there, I'm just going to concentrate on just the single output here if I can. Okay, so our power comes in to our transformer, and instead of coming in the center tap, it comes in one side. goes all the way through the primary coil, and then it ends up on the plate. Our entire waveform is generated by the one tube, so we don't have any of this breaking the signal into the positive and the negative going halves. Our entire signal, right from our, if we go over here to the preamp tube, here's our preamp tube over here. Okay, preamp tube comes in, and our signal is amplified here. It's a dual triode that they're using, but our signal is amplified. It's sent directly from the plate through a coupling capacitor directly over to our control grid on our output tube that fully modulates the plate. The other grids on here are suppressor grids because it's a beam pentrode tube. It can be operated as a triode or as a pentrode by just changing jumpers on here. There's actually a couple transistors in the design of this amplifier. If you look down here on the schematic, this is the first time I've seen the schematic. There's actually a couple transistors in here, but they're actually active in the biasing. Okay, this is your active automatic bias, and what this is for is this amplifier. You can plug in different types of tubes. It can take an EL34 or L6. I think it even will take a KT88. There's a half a dozen or so different tubes that can be plugged into this amplifier directly, and there's no adjustment required. That is all taken care of by this automatic biasing circuit that's in here. So they have no effect on the actual audio signal at all. These components are strictly to bias the different types of tubes. But it's a very, very basic circuit. There's just one tube. There's one tube for the preamp over here, and then one output tube, and it amplifies the entire waveform. Anyway, that's a single tube. When I grabbed the schematic for the other one that I built, it's a little easier to follow than this schematic. Let me grab it. So you guys that saw my construction video of the TU81 will remember this schematic. This one uses a single tube. It's a dual tube, so it's got a preamp stage in it, it's got a triode, and it's got a pentrode. So, but it's the same idea. It's a single-ended. Here's the transformer. Our power comes in from our power supply, goes through the transformer. We have a suppressor grid here to one of the screens on the tube, and our output. So our triode input signal comes in here on pin number 1. Grab my pen here to point this out. Signal comes in on pin number 1. Signal goes through the triode section, comes out as a pin number 9, where it's fed in through a capacitor to couple into pin 8, which is the grid for the output tube, which then modulates the plate with the signal. The plate voltage is modulated by the incoming signal on the grid, which of course imposes that voltage drop across the transformer, which couples that voltage drop into a current that is fed to the speaker. Vacuum tubes are voltage amplifying devices. In other words, they don't pass a lot of current, but they can control a substantial amount of voltage. So they amplify voltage, and it's the power of the speaker transformer that converts that voltage difference or that voltage drop into a higher current, lower voltage output, and that's why you've got your big winding here on the primary side and the small winding on the secondary side. The output is a low voltage but higher current to drive your speaker from the input. Clear as mud, right? Anyway, that's the fundamental differences between a single-ended tube and a push-pull. Let's crack open this thing and take a look at all the goodies in here, and then we'll start our construction process. This will be part 1 because this video, like the last one, is going to be done in multiple parts. It's not something that's going to go together all in one go, but I'm going to try and get this thing put together relatively quick because I'm anxious to try it out. So we'll crack open the box. Now when you buy this kit, it ships with not only Japanese instructions, but English instructions as well. So the English instructions come with a separate guide. That's the one I was showing you the schematic from. As you can see, I haven't opened this box yet. So this is the first time you're seeing the inside of what comes in the box here, complete with the Japanese instructions. But we didn't need the instructions for the last one, but this one, if you buy it in Canada, the States, or an English-speaking country, you get an English set of instructions that goes with it. But the serial number is only on the Japanese instructions. But they give you those as well. Here's our large circuit board. We've got some tubes, a couple of electro-harmonics, 6L6GC tubes. These are the output. These are Russian-made tubes, by the way. Let's take a look at these ones. These are worth a few bucks each, these tubes, for sure. So you don't want to drop them. I like that. Made in Russia. Gotta like it. So we're going to put the tubes back in their respective boxes, and I'm just going to put them out of the way for safekeeping for the time being. I don't want to end up with broken tubes before I get the unit put together. Things in the box. Oh, here's the these are the smaller tubes here. We'll just get them out of here. What are these? It says the Art of Electron Tube, but it doesn't have a brand on here, does it? Oh, it's a Shugang. Yeah, Shugang. And it's these would obviously be Chinese-made tubes. So let's take a look at these small signal tubes here. Yeah, these ones are from China. Here they are. 12AU7. This is just a dual triode, as you can see. You can see the two structures in here. Those are just very small signal tubes. There's two of those. And again, we're going to place them for safekeeping away from where the main construction is going to go on. Now we can start unpacking all of the other stuff that's in the box here. First we have the main cabinet. Get that out of the way. We have some feet. We have components. We have a couple bags full of components here. So the first thing we have to do is we have to sort through all the components. There's our power cord. I can go away for now. Some hardware, standoffs, our speaker binding posts, and everything. And then these are going to be transformers that are in here. You can just tell by the weight of these things. These things are going to be transformers, and they're all wrapped up. These transformers have all got connectors on them, which is a little different than the last one where the transformers were relatively small and they were soldered onto the board. But here is, okay, here's our output transformers. It's got a 5 ohm and an 8 ohm tap, which would be perfect because I have 6 ohm speakers. So that's speaker transformer number 1. This one is speaker transformer number 2. Done a good job of wrapping these up too. So here's our 2 speaker transformers. We'll just set them on my parts table. And then this bad boy, that's going to be the power transformer. Let's get a look at this. But here's our power transformer. Again, everything's connectorized. As you can see, we've got separate windings. We have our primary winding on one side and our secondary windings on the other. This is a good design, heavy power transformer. So now we've got the components all out. The next thing to do is to get the bench ready to start the assembly. Then we have to do is get the circuit board prepped So I'm just going to open up the package here and take the board out and separate all the individual boards, as they're all in one piece. Okay, these are our stickers, our warning stickers to put on the cabinet when it's done. And it's giving me warnings that there's high voltages inside. Yeah, it's a tube amp. What do you expect? Of course it's got high voltages inside. Okay, first we have to separate our boards, and the boards should just pop apart. Should be able to snap that out. There's one board. Second board. Third board is there. And I think these are all part of the main board here. Let's see here. Unit 2. Gotcha. Unit 3. Yeah, do not chop here. Yeah, okay. Yeah. I can just see somebody snapping that off, right? We'll have to put a little note on there. Do not chop here. Okay, here's all the different boards. Ready to go. Okay, now let's get the bench going. Let's get the bench set up here and start. I'll start with the assembly instructions, English ones. Like before, I'm going to set the camera up on the other little tripod so that I can actually film the actual process, and we'll do this all in sections. First thing we're going to mount is we're going to mount the 180 ohm resistors. There are 4 of them, R17, 18, R65, and R66. So let's find our 180 ohm. It's brown, gray brown is our color code, so let's just find them first of all. I think all the resistors are probably in their own separate bag. This looks like brown, gray, brown. Yeah, this is our ones here. So there's more than 4, but there's 4 to install now. R17, 18, 65, and 66. So I'm going to pull 4 of them out of the bag here. So now we have to find the locations. They go on board number 1 here. R17 and 18. Okay, R18 is here, R66 is here, R65 goes over here, and R17 is way over here. So I've got my 4 resistors out. I've already mounted 2 of them. So we'll mount the other 2. Most of the time building a project like this is finding where the parts go. Because when you've got a lot of components on a board, until you start to get the board populated, when you've got nothing on the board, you're looking at a lot of blank space. As the board gets more populated, it actually gets easier because you're running out of places to mount them. So we're going to bend the wires over on the bottom side of the board here so we can solder them down. And I just got some new solders. My other roll was out. So this is the first time I've tried this brand. It is a 6040 solder, so hopefully it's going to be okay. It's not Kester though. I've always used Kester, and I couldn't get any at the local place that sells all this stuff. All they carry is their own brand, which is probably Chinese garbage, but we'll see how well it flows. Incidentally, the last amplifier that I built, the other tube amplifier, it will be going up for sale if any of you out there is interested in a tube amp. It will be available if someone wants to buy it from me. Make me an offer. Because I'm going to keep this one and I'm going to sell the other one. The other one sounds great, fantastic sounding amplifier. It's just I want a little more power, as my speakers that I'm using are not very efficient. They're good speakers, but they're not that efficient. And it sounds very good at normal listing levels, but for a little bit more volume, I think having a few extra watts will make all the difference in the world. Okay, first 4 components have been mounted. Let's check them off on the checklist up here that we've done the first 4. This brings me back to my Heathkit building days, and I did build several Heathkit products when I was younger. I just wish I had kept them. A lot of them went in the garbage. I have a series of 22k ohm resistors here. There's 6 of them. Let's dig out the 22k. These are all half-watt resistors, by the way. There are some 1-watt resistors that go on the board here, but these ones are half-watt. So let's dig out the 22k. Those are red, red, orange, by the way, for those following at home that don't know their color codes. And this looks like them right here. There's 6 of them, and there's 6 of them in the bag. So let's dig those out, and we'll get those ones mounted. They go in R25, 26, 29, 30, 33, and 34. So let's locate the first one. The first one is R25. There's R26. So 26 is one of them, so we'll just put 26 in. Well, I've spotted it on the board. It goes right in here. And more than likely 25 is going to be on the other side of the board over here, which it is right there, because it's a 2-channel amplifier, so one's going to be near one tube and one's going to be near the other. So there's 25 and 26 mounted, and the next one is 29 and 30. So I'm going to guess that 29 and 30 are going to be, one's going to be on this side and one's going to be on the other. So let's find, there's 30 there, so 30's here, so 29 will be on this other side. So let's get 29 and 30 mounted. So there's 30. And 29 will be over on the other side here for sure. There it is, right there. And 33 and 34. And 33 is here. And 34 will be back on the other side. And 34 is going to be right over here in the corner. We'll get those ones soldered down. Now we'll mount the 1 watt 27K resistors. They are red, violet, and orange are the colors for them. There's 4 of them here, so let's mount those. So we have our 4 resistors. R7, 8, 13, and 14 are the locations. So let's find 7 and 8, 13 and 14. These ones go down here in the middle of the board. There's 7 and 8, 13 and 14. So all 3 of them, or all 4 of them, I should say, in a row with each other. Next we have the 10Ks to go in. That's R27, 28, 31, 32, and 62. So now we have to find those ones. 27 and 28 go right here. 27's over here in front of this transistor that controls the bias, and 28 is on the other side over here. '31 and 32 are over here. 32 is over here. Between 34 and 65. And 33 is over here next to 33. So here's, sorry, 31. 31 is over here. One thing I can say is that this new solder I've got is not as easy to work with as the other stuff, that's for sure. Even though it's thinner and it's still rosin core solder and 6040, it just does not work as well as the other stuff. And the last one is 62. The last 10K is 62. And it's right over here. Next resistors are the 330K, which would be orange, orange, yellow, R9, 10, 57, and 58. Gotta find them here. It's getting a little easier. R9 and R10 go here. So there's R9 and R10 over here. Mount those two first. Like the previous build, this video will end when the resistors are mounted, so you'll have to come back to watch me complete this. As it's not going to be completed tonight. It's going to take me a few days to build this thing. So actually more parts on this one than there was on the other unit. Okay, so those two are 9 and 10. I'm looking for 57 and 58 now. Okay, 58 goes here, 57 is over here. Probably one of these looks like a MOSFET. That would be in the bias control, I believe. I haven't looked at the schematic yet, but that's more than likely what those are in. Or there could be heater control too. So 57 and 58 down here. Let's have R64, which is a 0.47 ohms, so that would be yellow, violet, and silver are the band colors on that, and that is R64. So when you get a low value resistor like this, it's typically used in protection. They're using, a lot of times they use them as a fuse. R64 is right in front of the big filter capacitor here, and it is what I thought. It is connected to directly to one of the diodes here. This is the diode block over here. So it's going to be a protection in case something shorts, and rather than cause more damage, the resistor will go open like a fuse. Very common in electronics to use what's called a fusible. They use to put a flame-proof resistor in, and it acts as a time delay fuse, because it takes time for the resistor to get hot and go open, but it will limit the amount of current. Okay, now we have a whole bunch of 100K resistors to mount now. So let's find the 100K resistors and get mounting all these ones. The color black, or brown, black, yellow, and I have a bag full of them right here. These are going to be all the 100K resistors, so let's populate the board. It's R1, 2, 15, 16, 47, 48, 49, 50, 51, 52, 55, 56, 59, and 60. Let's populate those ones. The first two are 1 and 2, right on the edge of the board here. So we'll get those two tacked down first. I typically don't want to mount too many of them at once, because when you do that, you turn the unit over and half them in 16 are next to these capacitors C9 and C10. You guys wonder what all that noise in the background is? It's the heaters running. It's cold out here right now. It's December 25th, right in the middle of winter, and it's cool outside, so the heat has come on. Okay, now I have our 47 and 48 to locate. Our next four, 47, 48, 49, and 50. They're all next to each other, so we'll mount these ones all at the same time. There's 47 and 49. Okay, those are checked off. 51, 2, and 5, 6, 9, and 60. So 51 and 52. So say they're getting a little easier to find now. There's 52 and 51 is over here. So here's two more to go in. They're getting a little bit easier to find now that the board is becoming more populated with resistors. The first few are always the most difficult ones to find. And as you start to use up the spaces, well, it gets a little quicker to build things. But overall, I find the engineering on these boards has just been fantastic. It's one of the best design kits I've seen in a long time. And I mean, I've built tons. Long before I was putting these videos together, I was building all kinds of different things in kit form when kits were still relatively available. That would be the Heath kit days. I forget how many things I built over the years with Heath kit, but I built a couple of amplifiers for ham radio, like linear amplifiers, and frequency counters, and I'm gonna get my frequency counter I built and fix it one of these days because it's not working. Its internal batteries went bad on it, and I think it caused another problem. Okay, but anyway, I built cameras, video cameras, and all kinds of radios over the years. And some of them were better designed than others, but as far as the actual layout and ease of construction, this is going to be one of the best kits I've seen. This one and the one I made prior to this, very well laid out. Okay, 55 and 56. Let's find 55 and 56 now. 55 is there, 56 is there, and 59 and 60. So there's four of the last four of the 10Ks are right next to each other. So let's mount all four of those. Move on to the 12 ohm resistors. There's looks like there's 1, 2, 3, 4, 5, 7 of them. So R3, 4, R3 and 4, 19, 20, 21, 22, and 61. R3 and 4 are at the front of the board here. Okay, R 19 and 20, 21 and 22. Here's 20 and 22, and 19 and 20 are over here. That's the next four of these 100. They are 12 ohm. Okay, where are we here? 19, that was 19 and 20. or 20 and 21, so 19 and 22 are the other two that were over on, where was they? They were on this side over here somewhere. Here we go, 19 and 21. Yeah. We're getting to the final resistors to go into this board, and I say when the resistors are mounted on this board, that will close out this video, because the series is going to be long as it is. And even though I am trying to keep it shorter than longer, when I cut too much, I get people that will send me comments about why I cut so much, and that they want to see more of the construction process. So I'm trying to keep as much in here as I can without making it too boring. That's why I'm doing this over a series of 3 or 4 videos to assemble this thing, because I want to give people a realistic expectation as to how long it's going to take, especially if someone wants to put one of these together, which I'd highly recommend if you've got the money. This one is not inexpensive. The other one wasn't that inexpensive either, but this one is about 3 times the price of the other one. So it's not an inexpensive kit to build, but it's an inexpensive way to get into a Class A amplifier. Let's put it that way, as opposed to going out and buying one. The 2-watt single-ended amp that I built in the prior video, the kit in Canada sells for about $350 plus tax. The closest competitor of the same design of amplifier is built by a local boutique builder, and he's asking just under $900 for an amplifier of the same design using the same tubes. This kit here is about $1,000 Canadian, $775 US through the distributor, and a comparable amplifier of this design, I think I've seen them around $2,500. So it's a lot less money to build your own, and you're getting basically the same quality, depending on your construction, how well you build them. But it's less expensive. I shouldn't say inexpensive, because anytime you're working with vacuum tubes, you're talking a lot of money. But it's less money to build your own than it is to buy one that somebody else has already built. And if you like working with electronics, this gives you the enjoyment of actually building it. And you get the satisfaction. I think it probably sounds better too, right? At least psychologically, it's going to sound better, and you build it yourself, right? But anyway, you get the satisfaction, and hopefully a few people that see these videos will go out and buy one of these kits. And I'm trying to make things a little easier to assemble by showing you guys where the parts actually go. R61 is right here in the corner of the board. Now we move on to the 1K resistors, and that will finish off this board. So here's our pack of 1K resistors, and we'll get those mounted. And see that when I finish the 1K resistors, that should finish all the resistors up on this board, and that'll finish this video. So we'll start mounting the 1Ks. They are R5 and R6. Let's find 5 and 6. Should be getting a little easier to find things now that we're getting down to the wire here. There's 5 and there's 6 right next to 4 and 3. There is a warning in the instruction too about mixing up the 12 ohm and the 1K, because of course they use the same color codes, it's just the bands are different locations. One is brown, black, red, and the other is brown, red, black. So they even have a note in the instruction manual to warn people to be careful. I guess that's been a problem, and maybe when people have had problems assembling them, they've sent the kits off for checking out. They found that they've got the resistors mixed up, so that's one to be careful, and they've even made a note of that. in the manual. If you're not sure, measure them with a meter. But then again, anyone who's colorblind shouldn't be putting together electronic kits anyway, right? Okay, that's the first two there, R5 and 6. Let's find R11 and 12. 11 and 12 right here in the middle of the board, next to a couple of the electrolytic capacitors, which will be going on, and I'm sure it's the next video that we'll get to the capacitors, but there's 11 and 12. R23 and 24 are the next two 1Ks. 24 is over here, 23 is on the other side of the board over there. There's 24. And 23. '53 and 54 are the next two, again on opposite sides of the board. 54 is over here. And 53 is on the other side. '53 is there. Sorry about the reflections there, and this light tends to be kind of reflective off the board right into the camera. I can see that whenever I glance over it. Like, not much I can do about it because I got to be able to see what I'm doing. And 63 and 67. There's two more. There's going to be a few resistors left over. They probably go on other boards. That's why there's a couple of extra ones in the package here. But 63 and 67 are the last ones on this portion of the kit. So 67 is here, and 63 is probably, where is it? 67 is there, so 63 has got to be somewhere around here. But I'll put 67 first. '63 is up here, really on the opposite side of the board, and that should do it for all the resistors for this board. So there we have it. Looks to be all the resistors are mounted down now for Unit 1 for the TU8200. And thanks for watching this video, and we'll catch you in part 2 where we continue and start mounting, I guess it's the Zener diodes and diodes, the next ones, and photo optocouplers and stuff. That'll be in the next video. We'll catch you in the next one. Thanks for watching.